All right, chapter 10, pardon me, chapter 10, problem 15. So we got a wheel that starts at rest, and it is going to go through constant acceleration, alpha equals 3 radians per second squared, and there's a 4-second interval in which it turns through 120 radians. And the question is, how much time did it take to reach the 4-second interval? Well, to solve this problem, let's first rephrase it. And what we're going to do is we're going to start where this 4-second interval begins. And so we've got some initial position, we've got some initial velocity, we have time plus 1/2 alpha t squared, right? So this theta naught corresponds to the beginning of the 4-second interval, and this omega naught corresponds to the beginning of the 4-second interval. Why do we do this? Well, we're doing this because we have a few too many unknowns, but we do know theta minus theta naught is 120 radians. And we do know that the time interval we're interested in is 4 seconds. All right, so 120 radians equals omega naught times 4.0 seconds plus 1/2 of 3.0 radians per second squared times 4.0 seconds squared, right? Divide by 4 everywhere, 4 into that, 30 radians equals omega naught plus, okay, I divided by 4, that 4 went away, one of these goes away, that's 4 divided by 2 is 2 times 3, so 6.0 radians. Oh, sorry. And I divided by 4 seconds, so that's now seconds. This is seconds, right? And so we get right away to the initial velocity is 30 minus 6 is 24 radians per second. Okay, how much time did it take to reach the 4-second interval? Now we back up. And we back up to the very beginning of the problem, and we have omega equals alpha t. Now, I'm going to put in, let me do some things here. All right, I'm sticking in the primes just to indicate that we're not talking about the actual beginning of the problem there when we have that omega naught, just to make that distinction, right? Just to make that distinction. This is the omega naught that we are looking for at the beginning of this 120 radian segment. Okay, so now go away. Now I can go in here and I can put in omega naught plus alpha t, which is the equation we're accustomed to. Now we're back at the beginning of the problem, and omega naught is 0. And so we're looking for the point at which omega equals alpha t. We're looking for the point at which t is this 24 rads per second divided by the 3.0 rads per second squared, right? So 24 divided by 3 is, what is that, 8? So 8 seconds. It's too early in the morning, haven't had enough coffee. Right, 3 is 8, yes. Okay, so it took us 8 seconds to reach the 4-second interval that we were looking at in the first half of the problem, right? This first half of the problem is the 4-second interval. This last half of the problem is starting back at the beginning. And it took us 8 seconds to reach that point. And that's it for problem 15.